Determinant of order 3. We have successfully looked at the determinant of order 2. We are extending our teaching to determinant of order 3. First and foremost, let's look at this. Transpose of a matrix. If A is a matrix equal to A, B, C, D, the transpose of this matrix is A, B, C, D. All we need to do is the first row in the first matrix becomes the first column in the second matrix, and the second row becomes the second column, just as we have written it out here. Similarly, if a matrix P is equal to A, B, C, D, E, F, G, H, and I, the transpose of this matrix, which is a 3 by 3 matrix, will also follow the same principle above. A, B, C, D, E, F, G, H, I. This will become the transpose of the matrix P. Now, if A is a matrix A, B, C, D, E, F, G, H, and I, a 3 by 3 matrix, where the determinant of this matrix, written determinant of A, will be equal to this. The bracket is no longer used here, but it is the what? The bar, indicating that we are looking for what? Determinant. This is how you represent determinants. This is not a matrix, but now it's a determinant. Now, to find the determinant of A, you take the first element of A, which is positive. I will explain why it is positive later. Then you destroy every item on the column of A and every item on the row of A. What you have left in that determinant is E, F, H, and I. The next element on the first row will be signed as minus B. Then you do the same thing you have done earlier, and you will be left with this determinant. Then the next element will be signed positive plus C. You do the same thing. You destroy everything along C and along the row. You will be left with D, E, G, and A. We are back to the determinant of order 2. So the same principle holds. You cross and you cross. You multiply this and you multiply this and find their difference. So your A there, you do that. Your minus B, you do that. Your plus C, you do that. And this will now be simplified to give you the determinant of that 3 by 3 matrix. Now, I said I will explain to you the signing. What do we mean by this? How do we carry out the signing? An element in an even sum of the row and column takes a positive sign. Let me explain. For example, the element in row 1 and the column 1 has 1, 1. And 1 plus 1 is 2, and 2 is even. Therefore, you will sign that element like the A we discussed above as plus a positive sign. You follow that element. But an odd sum takes a negative sign. Let's take, for example, R1 and C2. The element in row 1 and is in column 2. We have 1 plus 2 equal to 3. Element in column 2, in row 2 and in column 1, we have 2 plus 1 equal to 3. As long as the addition, the sum is equal to an odd value, it can be 3, it can be 5, it can be 7, and so on and so forth. Then you assign the negative value to that element in that particular position. You can use any row or column to calculate the determinant of a matrix, in particular a row or a column with 0 entry. What I'm trying to say here is that in determinant, you can use any row to calculate the determinant. You can also use any column to calculate the determinant. Most especially or particularly, you use the rows or the column that have 0 entry. The obvious reason is that when you multiply any value by 0, the result will always be 0. So that will make it easier and faster for you to calculate the determinant of that particular matrix. Note the following. Number 1, if the determinant is not equal to 0, and the determinant of x, the determinant of y, determinant of z have any value, the solution is said to be consistent and unique. In other words, what we are saying here is that when you are solving a simultaneous equation involving 3 variables or more than 2 variables, you have a situation where you have to find the determinant. If the determinant is not equal to 0, and of course, these values of delta s, delta y, delta z have a value, it could be 0, it could be 1, it could be 3, it could be any number, then the solution you get is said to be consistent and unique. That is number 1. Number 2, the solution is inconsistent if the determinant is equal to 0, even if the other variables are not equal to 0. In other words, no solution as division by 0 is undefined. We all have said this before. We must have observed this in our normal classroom situation. Division by 0 is undefined. At the higher level of mathematics, they will tell you it is infinity. Now, number 3, we have dependent and infinite number of solutions if the determinant is equal to 0 and the other variables are also equal to 0. In this case, you have dependent and infinite, many solutions, uncountable solutions. That is the case when this happens. Now, invariably, we look at the application area of the matrices. One of the application area of matrices is looking at the area of a triangle with vertices s1, y1, s2, y2, s3, y3. This, of course, when you join the points together, you will be having a triangle, maybe a triangle like this. You have a triangle. Then you are asked to calculate the area of this triangle. Before now, we are conversant with all you know this point, you know this point, you know this point. A longer process will be for you to find the distance from here to here, the distance from here to here, the distance from here to here. Thereafter, you use Hero's formula to find the area. But again, the use of determinant can also help us to simplify this process. To find the area, thought the area A is A equal to half of the determinant of S1, Y1, 1, S2, Y2, 1, S3, Y3, 1. So this one is a constant for each of the points that you have written down in the determinant. You can now find the determinant of this, and half of that determinant will give you the area of the particular triangle being discussed. But if the determinant of A happens to be equal to 0, then the 3 points are collinear. What do you mean by being collinear? That is, they are on the same straight line. Like as you have this point here now, they will be on the same straight line. That's what we mean by being collinear. They are on the same line. Now, the lines such as A1s plus B1y equal to C1, A2s plus B2y equal to C2, A3s plus B3y equal to C3 are concurrent, that is, they meet in one point if and only if the determinant of these variables are equal to 0. Sorry, the determinant of the constants are equal to 0. Recall that we have written the equation A1s plus B1y equal to C1. That's exactly what we're putting here. We're putting the constants. So A1, the constant, the coefficient of S, B1, the coefficient of Y, C1, the constant term on the right hand side. Everything now brought together, and then find the determinant. If it is equal to 0, then we say that those 3 lines are concurrent lines, which means they meet at a point. Possibly they have something like this, they have something like this, and they have something like this. They are all meeting at a point, concurrent lines. Examples. Use the matrices below to answer questions 1 and 2. The matrix P is equal to this and Q is equal to that. Number 1, when P transpose is the transpose of P, calculate the determinant of P transpose. When S is equal to 0, Y is equal to 1, and Z is equal to 2. The second one is PQ is equivalent to A, B, C, D. Which of them? Let's start with the first one. Solution to number 1. Our P, where S is equal to 0, and then Y is equal to 1, and then the Z is equal to 2. This is the matrix P, and then we can find the transpose of the matrix P, and the transpose of the matrix P will be 0, 3, 0, 2, 1, 3, 4, 2, 2. Thereafter, we will find the value of the determinant of P transpose. 0, 2, 4, 3, 1, 2, 0, 3, 2. Now, we shall use the column that has more zeros. This is your plus, minus, and plus. So this becomes, the 0 will go, then we use minus 3. We destroy this, and we destroy this. We are left with 2, 4, 3, 2. Find the value of this, minus 3. 2 times 2 is 4. 3 times 4 is 12. The result of this is minus 3 times minus 8, and that is equal to 24. And that is the determinant of the transpose of the matrix P. Number 2, the solution. We are told to find the equivalent of PQ. It's equivalent to what? Observe that PP is the same as P squared, which cannot be equal to PQ. From what we have as the matrix for P and Q. Then you also observe again that P will give you an identity matrix. And of course, PQ is not an identity matrix. Our QP cannot be equal to PQ. Matrix multiplication is not commutative. Matrix multiplication is not commutative. From the knowledge of binary numbers, binary operations, we learn about commutativity. So QP is not equal to PQ. You multiply this matrix by this matrix, or multiply P by the other matrix, the two will not give you the same value. So, if these three are not equivalent to PQ, the only correct option, therefore, is P transpose P is equal to PQ. This is the correct option, and the answer is option A. You can try this on your own. Multiply the matrix P by the transpose of P. Multiply the matrix P by Q, you discover that they are equal. Example number 4. Find the area of triangle PQRO with vertices P, Q, and R. Solution. To find the area of this, we can actually find the area using the triangular form, distance formula. This is your point P, maybe this is your Q, and maybe this is your R. I'll take it this way, P, Q, and R. By distance formula, you can find the distance from here to here, you can find the distance here, you can find the distance here. Suppose this is A, B, and C. You can now use the hero's formula to find the area of this triangle. You recall that the hero's formula is equal to S into S minus A, S minus B, and S minus C. Everything here is under square root. And then your S is equal to A plus B plus C all over 2. I will encourage you to try that and see if your results will agree with what we are going to get using determinants. Alright, now we want to use determinants to solve this problem. Now with this, we have our A to be equal to half of 2, 5, 1, 4, 9, 1, minus 2, 3, 1, using determinant. We have put them in this form. So what do we do next? This becomes our half. Open the bigger bracket. We have signed the elements here. With this signing, we take the first one, which is plus 2. Open the bracket. We destroy everything here and also cancel everything here, leaving you with the this second one. 1 times 9 is 9, minus 3 times 1, which is 3. Close that, bring in your minus 5, open the bracket, this will go, this will go. You are left with 4 times 1 is 4, minus 2 times 1 is minus 2. Minus 2 times 1 is minus 2, so which will give us plus 2, because it's going to be minus whatever the product is. The next one is plus 1, and then of course what will you have? This is going and this is going. So 3 times 4 is 12, minus 2 times 9 is minus 18, so this is plus 18. So you now close the bracket. So from here you simplify, this is your half. This is 6 times 2 is 12. This is 6 times minus 5 is minus 30. And then you have another 30 there. Minus 30 plus 30 is 0. So you are left with half multiplying 12. And the result is equal to 3 square units. That's the area of that particular triangle formed by the vertices P, Q, and R. We have example 5. What type of matrix is matrix P? This is the matrix P. What type of matrix is this? Now, for us to determine the type of matrix that is here, it's obvious that it's not a zero matrix because all the entries must be zero for it to be a zero matrix. It's also obvious that it's not a column matrix. A column matrix will have only a column. Here we have more than one column. Then the symmetric matrix means that when you even transpose the matrix, it will remain the same thing. So in that case, our solution to be a solution. The answer is a singular matrix. Answer is equal to singular matrix. Singular matrix. And this is option B. Now we can verify what we have said by calculating the determinant of this matrix P. The reason is that the determinant of P, that is 1, into, this is gone, that is 4 minus 0. And then you have plus minus plus, so this is minus 1 into, this is gone. So we have 0 minus 4. The result of this is equal to 4, and then minus, this is plus now, and that is minus 4. The value is equal to 0. And when the determinant is equal to 0, the type of matrix is called a singular matrix. Example number 6. The following matrix gives the prices of articles by size and type. in naira. The matrix is P. This is the article S, article Y, article Z. By size is 60 and by type is 20 according to the code. For Y is 40, 30, for Z is 50, 80. If all prices were decreased by 20%, what will be the new prices? Matrix Q. Solution. First of all, to decrease is equal to your, by 20% means we have 100 minus 20 all over 100 times each of them all over 100. This is the decrease. So that will become 80%. For S, we now have 80 over 100, and 80 over 100 is the same thing as 4 all over 5, multiplied by the entry. The first entry is 60, this will give you 48. The second value for S will now be multiplied by 4 over 5 times 20, and that will give you 16. For Y, you have 4 over 5 of the first entry there, which is 40, and that is equal to 32. The second element for Y is the same 4 over 5 multiplying 30, and that is equal to 24. For Z, we have 4 over 5 or 50, and that is equal to 40. The second element of Z is the same 4 over 5 times 80, and that is equal to 64. You will recall that we are talking about reduction. Therefore, Q is equal to S, Y, Z, and then this becomes 48, 16, 32, 24, 40, 54. And we have solved the problem required of you. Question number 7 is an example. If the determinant of this element is equal to the determinant of this element, find the value of A. Our solution will be as follows. Since it is a determinant, we multiply, so we have A squared minus 2A is equal to 5 times 6 is 30 minus 6. This means A squared minus 2A is equal to 24. The result that A squared minus 2A minus 24 equal to 0. So we now have A minus 4, A minus 6 equal to 0. I'm trying to factorize. Because this one is minus, then this will be plus. Because plus 4 times minus 6 is minus 24. Plus 4 minus 6 is minus 2. So, therefore, our A plus 4 is equal to 0, or A minus 6 is equal to 0. As a result of this, our A will be equal to minus 4, or it is equal to 6. And this is the solution that you are required to. Example 8, given that the matrix A is equal to this, we are told to obtain A plus A transpose, bracket open and closes, transpose. Our solution, first of all, we write the transpose of the matrix A, and that will be equal to minus 2, 4, 1, and minus 6. Then we have to add the matrix A to its transpose, and that will give us minus 2, 4, 1 minus 6 should be added to minus 2, 1, and 4 minus 6. The result of this, component by component, minus 4, and then that is 5, and here is 5, and here is minus that is minus 12. This is the sum of the matrix A and the transpose of that matrix. Now that we have gotten that, we can now write our A plus A transpose, again transpose, will be equal to minus 4, 5, then 5 minus 12. And then this is the transpose of the matrix. You will realize that nothing changed because of the values that are involved. The elements in the main diagonal, when you transpose, do not change. In most cases, it's the elements in the other diagonal that are interchanged for the 2 by 2 matrix. Question number 9. If D is equal to this determinant, find D raised to power half. Solution. First and foremost, we find the value of D, and that is equal to evaluating the determinant 7 times 6 minus 3 times 2. This becomes 42 plus 6, and this is equal to 48. But we are required to find D raised to power half, which means we are looking for the square root of 48. That is the meaning. The square root of 48. In other words, this becomes 16 times 3 all under square root. And so the square root of 16 is 4. Remember your solve, and then this is root 3. And that is the solution to the problem. 4 root 3. Let's now take a look at question number 10, an example. Given this determinant and the test the result is equal to 7, find the value of S that satisfies this system of equation. S plus y minus 2z equal to 1. S plus z is equal to minus 1. And 2s minus 2y plus z is equal to 1. Our solution. We are going to use Cramer's rule to solve this problem. From what we have the matrix, let's call it matrix A. We write out the matrix form: 1, the coefficient of S, 1, the coefficient of Y, minus 2, the coefficient of Z. We also have a similar one: 1, the coefficient of S, 0, the coefficient of Y, and 1, the coefficient of Z. Then we also have the next one: 2, and then minus 2, and then 1. This matrix formation, and then the variables S, Y, and Z accordingly, and this is equal to, the result we have is 1, minus 1, and 1. This is what we have. Now, we have put it in the matrix form. We are interested in looking for the value of only S. But before we do that, we have been told that the determinant of what you have here now is what you have at the beginning. So we have our determinant is equal to 7. You don't need to calculate that, it's already done for you. What we now need is to find the value of the determinant of S. And we said that you replace the column that carries the S variable, the coefficient of the S variable, by the right hand side. So we replace 1, minus 1, and 1. Then you have your 1, you have your 0, you have your minus 2, you have your minus 2, you have your 1, and you have 1. Then you are going to evaluate this one. You evaluate this one accordingly. So if we have to evaluate this, what will be the result of this evaluation? So we have delta S will be equal to, I can use any of the rows and columns. Let's just use the first one or the second one. Let's use the first one. So we have plus 1, and then what remains is 1 times 0, which is 0, and then minus 2 times 1, which is minus 2. So eventually you have plus 2 in that case. Then you have your minus 1 comes in again. You have destroy that line, and then all that you will now have 1 times minus 1 is minus 1, minus 1 times 1, which is 1. Then you take on plus minus 2, which is minus 2, and what you have is minus 2 times minus 1 is 2, minus 1 times 0 is 0. So you simplify this to give you your 2, minus 1 is minus 2, times minus 1 is plus 2, and then you have minus 2 times 2 is minus 4. So what do you have at the end? You have that 4 minus 4 is equal to 0. Remember, you are told to only find the value of s. Therefore, our s will be equal to delta s all over delta. And the result is equal to 0 all over 7. And the answer is equal to 0. Exercise number 1. Find the non-zero positive value of s which satisfies the equation. This equation here, there's an equation here when you write out the determinant equal to 0. Options A, 2, B root 3, C root 2, and D is 1. Question number 2, the determinant of matrix, this matrix here, in terms of s is A, minus 3s squared minus 17, B, minus 3s squared plus 9s minus 1, C, 3s squared plus 17, D, 3s squared minus 9s plus 5. Question number 3, evaluate this determinant. The result, A, minus 42, B, 102, C, 8, that is 18, D, minus 102. Question number 4, if S is equal to 2, 3, 1, 4, this matrix, and Y is equal to this matrix, find the value of SY, determinant of SY. A, minus 55, B, minus 50, C, this is D, 77. Number 5, if this determinant is equal to this determinant, find the value of Y. A minus 5, B minus 4, C 4, and D 5. Here is the nugget for the day. The simple answer to your prayer is go to work. Nothing can come out of nothing. John Marston. Here are the answers. Option C for number 1, option B for number 2, option D for number 3, option A for number 4, option D for number 5.